Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eradinos, which is about 10 light years away from the solar system, and the speed of the spacecraft is 80% of the speed of light. That is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T0 equals to 2 times L0 divided by V. So the journey is from Earth to the star Epsilon and back from star Epsilon to Earth. So it is back and forth. So that is the reason that we need to multiply the distance between Earth and the star Epsilon, that is 10 light years. We multiply it by 2 because the journey is back and forth. So actually it is 10 years multiply by 2, and we divided it by the speed of the spaceship, that is 80% of the speed of light, that is to say 240,000 kilometers per second. So total way is 20 light years, 2 times 10 light years, divided by the speed, that is 80% of the speed of light. So the total time that it will take, the total time that is passed on Earth is 25 years. So on Earth, the time that is passed is 25 years from the moment that the twin brother left the Earth with the spaceship until he arrives to star Epsilon and then comes back to Earth. So the total time that it will take him, the total time that will pass on Earth is 25 years. According to Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus v squared divided by c squared. So the total time that will pass on the spaceship is the total time that passed on Earth, that is 25 years, multiplied by root of 1 minus v squared divided by c squared. Because of the fact that the twin brother that is in the spaceship travels at very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation or time lengthening. So, because the brother in the spaceship is moving at very high speed, so the brother on Earth sees his brother in the spaceship moving at very high speed. So the flow, the rate of time flow in the spaceship is slower than the time flow on Earth. Yes, that is the phenomenon that is called time lengthening or time dilation. So, actually, that is the reason that the total time that is passed on the spaceship is less than the time that passed on Earth. Yes, because the rate of time flow in the spaceship is slower than the time flow on Earth. So the total time that is passed on the spaceship during the whole journey is only 15 years. So it is 10 years less than the time that is passed on Earth because of the time lengthening or time dilation that occurs when someone is traveling at very high speed. But according to the twin in the spacecraft, he is at rest while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to Lorentz transformation, so the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared. So actually the distance between the Earth and the star Epsilon is 10 light years. When we measure the distance between Earth and the star Epsilon, when we are at rest, the distance is 10 light years. But when someone or something travels at a very high speed towards you, there will be a contraction of distance between you and the object that travels at a very high speed according to special relativity. So, because of the fact that the twin brother that is on the spaceship travels at very high speed, there will be a time contraction between him and the star Epsilon. Actually, the brother that is on the spaceship sees himself at rest, and the star Eridanus is moving towards him at very high speed, that is 80% of the speed of light. So, because of this, there will be a contraction of distance between the brother that is on the spaceship and the star Epsilon. So instead of 10 light years, that is the distance between that is the distance between Earth and the star Epsilon, the distance will be shrinked to 6 light years only. So that is phenomenon is called contraction of distance, and this is something that occurs according to special relativity when someone is moving towards you at very high speed. So there will be a contraction of distance between you and the other person, or someone or something that is moving towards you in a very high speed. There will be a contraction of distance between you and the thing that's moving towards you. So the distance actually between the star Epsilon and the Earth, or the the twin brother that is on the spaceship, will be only 6 light years. Okay, now because of the fact that the distance between the brother that is on the spaceship and the star epsilon is only 6 light years. So now we must calculate the total time that will take to the twin brother that is on the spaceship to do all the journey from Earth to star epsilon and back from star epsilon to Earth, back and forth. So now, because the distance shrink only to 6 light years, we must calculate the time that it will take to the brother that is on the spaceship to do the new distance, or to do all the journey back and forth from the star epsilon to Earth. Okay. So the total time that will pass in the spacecraft will be 2 times L spacecraft divided by V. So the L spacecraft is 6 light years. This is the, as I have already said, because of contraction of distance, the distance between Earth and star epsilon is only 6 light years. So the twin brother that is on the spaceship must to do the journey back and forth of 6 light years, back and forth. So the total distance will be 12 light years divided by the speed of the spaceship that is 80% of the speed of light. So the final result is 15 years. So it will take him only 15 years to do all the journey instead of 25 years that passed on Earth, because of the fact that the distance between Earth, or between the twin that is in the spacecraft to star epsilon, shrinked to 6 light years. So the total journey will take the brother that is on the spaceship, the total journey will be 15 years. Okay. So therefore the two twins effectively agree that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to time, due to the effect of time lengthening or time dilation, as I have already explained. And in terms of his traveling twin, due to contraction of distance. Yes, that's what I explained previously. So, from the point of view of the brother that is on Earth, now I repeat the explanation. From the point of view of the brother that stays on Earth, uh, because his brother is moving at very high speed in the spaceship, that there will be a time dilation or time lengthening, and because of time lengthening, the total journey will be 15 years. And from the point of view of the brother that is on the spaceship, as I've already said, he is not moving, and the star Epsilon is moving towards him at a very high speed, that is 80% of the speed of light, and because of this there will be a contraction of distance, and the distance between the brother that is on the spaceship and the star Danos will be 6 light years only, so the total distance back and forth is 12 light years, and because the speed, the total way is 12 light years, and the speed is 80% of the speed of light, so the total time that is passed in the spaceship will be only 15 years. Okay? Thank you very much.